Hello students, I know I said in the last video that I was going to leave you to try this on your own, but it's a bit of a complicated one, so I'll make a video to go with it as well. So it starts by saying that we have a sequence of equilateral triangles that are formed by connecting the midpoints of three sides of the previous one. Starting one has side length of 6, and the pattern continues to infinity. So what we've drawn here is sort of the pattern going inside, but we've got a sequence. The first one starts with 6. So I'm going to cheat a bit actually and copy this first one. Goodness. I'm going to use my straight line tool though to help me. So here's my first triangle. And I'm going to, again, like I said, cheat a little bit, use my tools and drag this over. So there's my first one. And it's a sequence. So my next one is formed by taking the midpoints and connecting them. Because I'm taking the midpoints, that means that I know that I'm forming 4 new equilateral triangles. So this triangle has 1/4 of the area of this one. So the next one in my sequence is this one on the inside. And so here's my next one, a little bit below it. All right, so I'm going to take that over, and we continue like that to infinity. So I'm looking at the sum of the areas. So if this first triangle has area 1, I know that my side lengths, it says 6, and now I need to turn off my straight line tool. If I put in a height here, well, I know that this bit's going to be 3. Using Pythagorean theorem, I know that this side is going to be square root of 36 minus 9. So that's going to be square root of 27. This is 27 is the same as 9 times 3. Square root of 9 is 3. So I can rewrite that as 3 root 3. So area 1 is going to be half times the base. Remember, the whole base has a length of 6 times my height. So half of 6 is 3, that gives area 1 an area of 9 root 3. Like I said, area 2 is going to be 1/4 of area 1. Area 3 is going to be 1/4 of area 2, but that's the same as 1/4 times 1/4 of area 1. So I could say 1/4 squared area 1, and I can see that I have formed a geometric sequence. So I have a geometric sequence where my U1 is area 1, my R value is 1/4, and since my R value has an absolute value that's less than 1, I can find the sum to infinity. That's going to be first term divided by 1 minus R, so 1 minus 1/4 is 3/4. That's going to give me 12 root 3 as my total area.